Hello there, my name is Charles Wells Fanim Sipa. Welcome to a presentation on evaluation of definite integrals by the method of substitution. The purpose of this presentation is to explain and present in a neat way the evaluation of definite integrals using the method of substitution. I'm going to use the following example. Let's say we're given a definite integral from 0 to 2 of x multiplied by the square root of x squared plus 1 dx. Now, it's clear that what we should remember when we are doing these problems is the following fact, that when we are given a definite integral from a to b of a function f of x dx, the task here is to find a function, let's say denoted by capital letter f of x, such that when we differentiate this function, capital letter f of x, with respect to its independent variable, in this case x, we should get f of x. Now is the integrand here. So once we've determined this function, then evaluating this integral will be as follows: to be integral from a to b of f of x dx, that will be equals to capital letter f of x, then you write this as a straight line and indicate they were evaluating that between a and b. Then the next, it will be the evaluation of this function at the upper limit. Now is the value of the function at the upper limit minus the value of this function at the lower limit. Then what you get here is a numerical value. I think also before we mentioned that this numerical value will normally be equal to the area between these two numbers, let's say a there and b there. That will be the area under the curve between these two numbers, or within this interval. So that will be the area. That will be the geometric interpretation of the numerical value we get here. So sometimes you will encounter this written as, in brackets, square units. In ours, it will mean that the definite integral will give the interpretation of area. Okay, so now coming to this exercise, we need to determine exactly the same type of function, or the function which has got the same status with this function, and then evaluate the integral. Okay, now our task is to evaluate this integral. I'll do this problem in using two approaches, and I've seen a lot of presentation of this, and some of them are a bit difficult to follow. In other words, the presentation of the solution does not flow very well. So I'll try here to present what maybe I would consider to be easy to follow and easy to read. So what this involves is we'll do integration by substitution almost exactly like we did it for indefinite integral, but we also need to consider that there are limits of integration here. So we've got also to work with limits of integration in terms of changing the limits of integration. So this will do as follows. First of all, we let our u be equals to x squared plus 1. Then we see that du dx will give us 2x plus 0, and then this is equivalent to saying du over 2 is equals to x dx. So as you can see, under integral sign, we've got this term x dx. Then we're going to substitute by this expression and the u by that. Then what follows here is going to be the integral of the square root of u du over 2. Then you see there, I haven't done anything with in terms of limit there. What is supposed to happen there? We need to evaluate u at the lower limit. So okay, I can write here u at 0, and the upper limit will be u at 2. So we can come back to this side and calculate the following, do the following calculation. So we can start by u at 0, which will give us 0 squared plus 1, and that is equals to 1. And then we get u at 2, which will be 2 squared plus 1, and that will give us 5. So this integral now is going to be the integral of u to the power half from 1 to 5, and du, and in this case you can filter out this half as a constant since the integration is linear. So we've got half the integral of u to the power half between 1 and 5. Then what follows now, we can do our usual integration. In this case, I've written in such a way that you can see that it's such that we should use power rule, because our power here is different from -1. So we're going to have here half u to the power half plus 1 over half plus 1. Then here we'd write a straight line and write the lower limit and the upper limit there. Then what follows now is we can simplify here, then evaluate. We note that this is going to give us 3 halves, which we can write here then as half times 2 over 3, and this will give us u to the power 3 halves. Then simplifying there, we'll get 1/3, and then evaluating this function here, we're going to get square root of 5 cubed minus the square root of 1 cubed, which we can see that this simplifies to square root of 5 cubed minus 1 over 3. I'll leave that as it is, the square root of 5 cubed. I would leave this as it is here, square root of 5 cubed minus 1 over 3, and that is very accurate, it's very exact. I would try to avoid the decimal numbers there if it's not necessary. So as it is, the definite integral has been evaluated and the whole process has been shown. You do a substitution. So doing a substitution, you need to change the limits of integration. Then you do your integration as we've done. Then it's done. So the other approach of this, or of doing this, is if one maybe found this a bit tedious and maybe not very clear, I'll suggest the following. You start with the integral, which is integral from 0 to 2, and this is the integral of x times x squared plus 1 dx. So I would maybe, let's say, I would to make a division there and leave that integral as it is there as a definite integral, and take its indefinite form, which will be as follows. So this integral, the only difference that this one has no limits, so it's the same integral. So then I will then let u be equals to x squared plus 1 du dx equals to 2x plus 0, which is this, what we're doing here is common in the two approaches. Then this again would be equivalent to du over 2 equals to x dx. Then coming this side, I would then substitute accordingly. Then we've got here u to the power half du over 2. Then filtering out half, would write here as integral u power half du. Then from then I'll apply our power rule and have u to the power half plus power half plus 1 over half plus 1 plus c, to write it correct way. Then simplifying this again, we're going to have half times 2 over 3 multiplied by the square root of u to the power 3 plus c, which is square root of u to the power 3 over 3 plus c. Then you're doing this as an indefinite integral, we would then do backward substitution to get back to the variable x. Then I would write this as x squared plus 1, which is our u, to the power 3 divided by 3 plus c. So now, having done this, maybe on the sidelines, but I think it's very important to show your working so that anyone who's looking at your work can follow what you're doing. So after this, I'll then come and finalize giving the solution to this exercise. This is what I would do. I would leave this part which we're working there clear as it is. Then come here and say, therefore, the integral x squared plus 1 dx from 0 to 2 will be equals to, I'll simply copy this expression because c in the definite integral will be redundant. So I'll copy simply that function there as square root of x squared plus 1 to the power 3 all over 3, this evaluated from 0 to 2. Then simplifying there, evaluating there, we'll get square root of 2 squared plus 1 all to the power 3 minus the square root of 0 squared plus 1 all to the power 3 all over 3. And the simplifying, you can see this is the square root of 1, because 1 cubed is 1, and this is the square root of 5. Then we get this as the square root of 5 minus 1 all over 3. And as before, I'll then leave this as the final answer and avoid decimal numbers there if it's not necessary. Okay, so now let's look at the last example in this presentation, which is going to be as follows. In this case, we're integrating the function ln, it's a rational function, over x, and this is a definite integral between 1 and e dx. Now here we will let, in this case, our u to be ln of x, and you can see that du dx is 1 over x, which is equivalent to saying du is equals to dx over x, and that's what we've got, dx over x there. Then we substitute that du. Then immediately then I would change the limits of integration. Value says u at 1, which will be ln at 1, and we all know that that is equal to 0. Remember, the graph of ln is more or less like this, intersecting there at 1, and then the value function is 0. Right, so then the next thing is to evaluate the upper limit, which will be u at e, and then this is ln of e. Remember, now this is same as the log base e of e, and that should be equals to 1. So now, having changed the limit of integration and having our substitution there, now we can now write here as integral of u du from 0 to 1. Then you can see that this is simple power rule. Then we integrate this as u squared over 2, and we evaluate it between 0 and 1. And in this case here, there's no, when we've got this, there's no need even to do backward substitution, because we've already changed the limit. So then we evaluate this as 1 squared over 2 minus 0 squared over 2, and then our numerical value here will be 1 over and then over 2. Then we will be done as far as a definite integration is concerned. I hope this is clear, and the explanation given here, I hope it can help you to present these solutions in a nice and a presentable way. Otherwise, for now, I would like to say thank you for listening. My name is Charles Suasfani Msip.